Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to answer the question that I know is on everyone's mind here. What are vertical and horizontal asymptotes? So what we're going to do is we're going to look at this function right here, y equals 4x over x minus 3. That's an example of a rational function. Rational functions are like fractional types of functions where you have polynomials in the top and the bottom, right? And what I've done here, I've already, to save a little time, is I have already generated a bunch of data points here that we're going to be talking about. And I put over here, how I'm generating them. For example, this first point came from looking at f of minus 5. And that means you take negative 5 and put it into this function. And I got 2.5 out of that. And what we're going to do is we're just going to start sketching this graph and talking about some of these points here. And then what asymptotes are should kind of follow out of that. So, all right, so this point, negative 5, 2.5, 1, 2, 3, 4, 5, 2.5 is about here. All right, negative 1, 1, negative 1, 1, 0, 0. Okay, 2, negative 8. Now you'll notice here when we go from 0 to 2, and here we want 0, 0 all the way to negative 8 here. So 1, 2, all right, 1, 2, 3, 4, 5, 6, 7, 8. That's way down here. Now, remember that when you're looking at the domain of functions, that I usually give people advice to assume all real numbers unless you can show otherwise via division by zeros or even roots of negative numbers. This function is not defined at x equals 3 here. So I'm going to put a little reminder here. The domain is all real numbers here except x cannot equal 3. So then the question is well, what happens to the function when we approach 3? So you can't really ask yourself, what is f of 3, right? This does not exist. We can't do that because the function is not defined there. But what we can do is investigate what happens as we approach 3. So 2 is reasonably close, and you notice that the function goes to negative 8, right? And then let's look a little closer. Okay, 2.9 is closer to 3, and you notice this function goes all the way down to minus 116. So, 2.9 is, like just, right approaching 3, and this is way down here, 100 units. Look at what happens if you punch 2.99 in. Now you get 11 or almost 1,200 straight down. And if I put 2.999, this probably would give me like negative 12,000 or so. So what's happening is in math language, we say that as x is approaching 3, and there's a little notation here. I'm going to put this minus sign, which means from the left. The function is going to negative infinity. And on the graph here, that means as we approach negative 3, the function is going straight down, right? And again, this line here, as this function approaches this minus infinity here, that's what's called a vertical asymptote. I'm going to go ahead and put that in red. Okay, the line x equals negative 3, I'm sorry, positive 3, not negative 3, is our vertical asymptote. Vertical asymptote. So what a vertical asymptote is it's the vertical line that the function approaches, either heading to plus infinity or minus infinity, as the function approaches the value where it's undefined, where the 0 is. All right, let's take a look at what's happening just to the right. If you put 3.01 into the function, that's just a little bit to the right here, you get like 1,200 and something. So that point on the graph, that's way up here. I can't even get this on my graph. If you put 4 in, we get 16. I can almost get that one. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's like right here. I'll just go ahead and put that there in my, right over that's just fine, I guess. 7, 7. So let's see here. We're at 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There's a point on the graph. Okay. I probably should have did about one more here, but because it's kind of tough to tell what's happening over on the right. But this thing, if we sketch it, maybe I will do one more. Let's see, 4, 16. Let's do 5, just to get one more point in here. Let's see, that's going to give us 20 over 210, I believe. Let me double check that. If I put a 5 here, that's 20 up top, 2 in the bottom, 10. So 5, 10. Let's see, 3, 4, 5, 1, 2, 3, 4, That's that function's way up here. All right. So what it does, you can start to kind of sketch this in here. This thing is doing this. I'm just going to go right through my stuff here, and it's heading to plus infinity. If we sketch over here, this function is doing this, and it's heading towards minus infinity. Now you see how handy the vertical asymptotes are for sketching this function. All right, I'll talk a little bit more about what's happening as x gets larger in both directions. And that's what the second guy does here, the second set of tables here. You notice that if I put in x equals 20, we get 4.75 out of that, so keep that in mind. If we put in x equals 50, again through this function, we get 4.26. X equals 100, we get 4.123. X equals 1,000, 4.014. You notice that the function, as we get bigger and bigger and bigger, the function appears to be approaching 4, right? And it is. That's what's called a horizontal asymptote here. Horizontal asymptotes are typically pretty easy to find. Let me write this over here. All right, so we got y is equal to 4x over x minus 3. For finding the horizontal asymptotes, we just do a quick approximation here. If x is really big, let's say a lot bigger than 3, then this bottom is approximately just x. So our function here, y, is approximately 4x over x, which is 4. So what this means is as x gets really big, either to the right or to the left, like 100, 1,000, 10,000, or negative 100, negative 1,000, negative 10,000, the function here is approaching 4. So y equals 4 is called a horizontal asymptote. I'm going to go ahead and draw that in. Let's draw those in green. Horizontal asymptotes just have a green feel to them. So I'm going to go ahead and, whoops, I don't want that like that. All right, so 1, 2, 3, 4, and I'm going to go ahead and sketch this. There's my horizontal asymptote for this function, and it just keeps going forever. And what that allows me to do is now go back and kind of expand upon my sketch here. This thing is approaching the horizontal asymptote in this direction. Same thing in this direction. So this could have probably turned out a little better, but I think I'll leave this for my first introductory video here on what these asymptotes are. To just kind of shorten it up here. Okay, where the functions go undefined because of division by zeros, that will usually give you a vertical asymptote. I say usually because there are conditions in where it won't, but I'll save that for another video. And then you typically draw those asymptotes in, and then you can use them as graphing aids. Once you have horizontal and vertical asymptotes drawn in, it becomes really easy to sketch functions. For example, had I found the asymptotes first and drew in the horizontal and the vertical, and then I plotted just like 1 or maybe 2 points, I can typically just sketch the rest in. Come over here, plot 1 or maybe 2 points, and then sketch the rest in. So asymptotes are wonderful graphing aids. They really are a great thing to get good at. So anyway, this is meant to be just an introductory video about asymptotes. I hope that everybody who's watched this has a little bit of an idea of what they're about. Have a great day.